know our teacher words. Okay, so we know how to say "jiso," "wei shama," "why," "1分钟," 1 more minute.
1分钟.
So those are all science teacher words, right? You have 1 more minute, you better finish. Somebody answer me. What's my question? Raise your hand and why. I think that's the most famous teacher word, isn't it? That's the word we always ask, is why. And Norman and I were teachers. I don't know what Shenyo said about our introductions as professors, but we were both classroom science teachers. I was a secondary biology and physics teacher. Norman was a secondary biology teacher before we went into university science education, teacher education. So we always say that, especially when we work with teachers, because we think that it's not always right to talk about how to teach secondary level students or middle school students or elementary students if you've never taught them yourself. So we take pride in saying we were classroom teachers too, and we enjoyed it. Today we're going to talk about teaching from an inquiry approach and a little bit of something called the nature of scientific knowledge. And then we're going to end with some examples of engineering, because in many countries that we work with teachers, they want to know about what is this thing called inquiry teaching, how to do it effectively, and how it makes my students learn the science that I want them to know better. So when should I please stop?
我做一点点很简短的翻译，我想大家都应该听得懂。这会讲得很慢哈，但是就怕说有些 miss 掉，我就很快的说。那其实我刚刚忘了介绍，就是两位讲者，其实他们都是曾经是中学老师，所以他们有经验。那今天呢，他的讲题里面包含了介绍什么是科学探究，那也谈一下科学探究的一些有些本质性的东西，或是科学的它的特性哈，所以大致上是他今天的上午演讲内容。
Okay. I have a big teacher voice, so I don't like to use the microphone if I don't have to. Can you hear me in the back?
Okay.
Yeah, I figured so. Usually people way back can hear me. So one of the things we begin with is this idea of scientific literacy. Because what is it that we really want our science students to know when they leave our schools? Yes, we want them to know the science that we teach. So who's a biology teacher here? Raise your hand.
有人教生物相关的科目吗？有。
Who teaches physics?
跟物理有关的。
Who teaches chemistry?
化学的，化学教化学的化学。
They're what? They're all engineering. Who teaches engineering? What else do they teach?
Well, some are research assistants, so they may have, some of them may have teaching experience, but...
Okay, all right. So you're coming from some different perspectives.
You can say that.
Okay.
They have different measures to check that one. So.
Okay, but you all have science interests, right?
Sure.
Okay. Good.
Science.
I don't teach English. But around the world, and Norman and I are pretty international where we work. People want to know how it is to make their children, when they leave school, okay, whether they go to college or not, whether they go on to university, they want them to be scientifically literate. They want them to know how to make decisions that have connections to science issues, scientific issues. And we know from our research that in a classroom, if you're teaching not only the content, but if you're teaching about how that content was made by scientists, what scientists do, and also what is this thing called science as a way of knowing, you end up having a more literate student. Most students, when they leave school, they may remember Newton's laws. They may remember photosynthesis. They might remember chemical reactions, but they seldom use it again. But they will use that decision making all through their life, okay, as consumers of science.
开始呢，他先从这些所有的想法是来自于一个名词，其实现在我们国内也常讲的跟科学素养，就是希望我们人民都有足够的科学素养或是科技素养。那这个素养的内容呢，不包含除了就是科学知识的学习之外，其实还应该带入的是对于科学知识产生的过程的了解，然后还有一些当然最包含的一些科学所谓的用什么样的方法、什么样的过程，那最终呢，我们希望人们有能力去用科学的方式去思考，然后在他的日常生活当中做出适当的甚至理性的决策判断，这样大概是科学素养这个名词我们的取向的重点，这样稍微说。
Okay, so this is our goal, and regardless of whether you come from the vocational areas or not, they're going to need to apply the science they learn to whatever jobs they have, but then they also have to apply it to life. So when I'm going to go to the, I should have to, I'm going to go to the short version. Actually, no, I don't have that one slide I want. Of all the slides, it's not there. Okay, so what we say is that a scientifically literate person can use science concepts, skills, and values to make responsible decisions. So if I go to a doctor and I want to know whether I can trust that doctor's diagnosis, I might say I should check with another doctor. Now, what if the other doctor gives me a very different answer? I have to make some decisions. Do I say one's wrong and one's right? Maybe not. Maybe they're just looking at my symptoms from two different perspectives. But I have to make some decisions about what I'm going to do. I have to be a scientifically literate person to be able to soundly consider my options and make those decisions.
这很快，就是他提到我们刚刚讲到运用在日常生活的决策判断。那他刚举的例子就是，当你看医生，如果医生给你不同的诊断跟不同的建议，我们有没有一个有科学素养的人应该有能力去在这当中做抉择。我们目的不是在说谁对谁错，而是你是在做自己个人的判断。
We also have to make some decisions about our environment. This is a green building, right? Okay, there were reasons why they built this building. Well, it's a magic building too, right? The magic green building. Why? Why do we want to have green buildings? Why is that better? If I'm going to build a greenhouse, or more energy efficient car, it may be that then I have to make a choice. The energy efficient car costs 3 times more than the less efficient energy efficient car. What do I do? Do I worry about the environment? Or do I worry about my pocketbook? So we have to make those decisions all of the time. And so having the students engaged in inquiry and problem solving and thinking about these things in the classroom is one of the few places they're going to have opportunities to practice that before they have to make those more important decisions in real life.
他举了个例子，就是我们现在在一个绿色魔法绿色魔法学校，那谈到其实现在谈到的跟环境有关的绿建筑是那个节能车等等的这些东西，但其实都要我们都知道这个价钱会比较高，那我们要怎么决定是要我们关心的是环境，还是关心到我们的钱？
Yeah. You just had demonstrations all over Taiwan, about 4 cities, about nuclear energy. So when you consider that, sure, no one wants the nuclear meltdown, but do they want to pay much more for energy, or do you want to be dependent on a foreign source of energy? So it's not that sometimes it's easy to just say, this is good or this is bad. You need to know all of the information.
是他刚才举的就看听到了nuke 的那个是的，他提到就是我们需要很多的讯息，我们应该要去从这讯息判断。
I don't want to know. So in curriculum in schools, we look to have inquiry as part of their education. It's as important as the more traditional science that they are learning in a general curriculum. And we know that in schools everywhere, students have physical science, life science, earth and space science, science and technology. So if you're in a vocational school, if you're working in architecture, civil engineering, automotives, you're looking at this link between science and technology. Also, there's science and personal and social perspectives. That's usually integrated into these classes, where there's a connection between the social personal perspective and the content that's being taught at that time in the class. And then finally, something about the history and nature of science to hold all of these together.
那因为前面他提到，就是在我们学校课程里面，那一般大概就是一般科学的课程之外，其实到了高中职到甚至大学，可能相关的议题就是整合了科学跟科技。然后其实还有另外一个重点，就是谈到他刚刚谈到在生活当中的思考判断。那这个其实不会是成为一个单独的学科，但它多半都是融入在我们各个学科里头，而我们应该设为一个，实际上设为一个目标，要让学生能够有机会去探讨这些事情。然后最后一个是因为一直都是他们的专题哈，就是就像我们刚刚讲，我们做什么事情可能是要追本溯源，知道之前发生什么事情，所以他谈到了历史，谈到了这一个也许是学科领域，或者我们在做的事情的本质到底是什么。
Okay, so if we're thinking about science in general and where it fits into your classes, we always ask people to answer this question. What is science? And we ask them to write down their answer.
通常都会一开始上课就是问这个问题，好，让大家写下任何一个写出来你认为科学 会去思考这个问题。
But this is one of those questions that everybody, if I said, do you know science? Do you know what science is? Everyone would say yes. But if I say, write down your answer, you say, oh, that's hard. Right? I even look at this question sometimes and say, oh, that's hard. Because it seems too big. And it is, because you can't just write one thing down and say, this is science. So some of you might say, oh, science, oh, that's physics, that's chemistry, that's biology, right? That content. How many thought of that when you think about this question?
当他问到科学是什么时候，第一个会想到是这些学科科目的基础社会。
All right, some of you might have thought, oh, experiments and asking questions and doing investigations, collecting data. How many of you thought about those things? Sure. You would both be right. And then some people think, oh, science, that's a way to understand the world. It's a way of knowing the world, the universe. Did anybody think of that as an answer? And you would be right too. That's why it's so hard to answer this question. It's all three of those things. It is a body of knowledge. When we talk about science, it is that content. It's not about learning Mandarin. It's not about learning how to write poetry or art. It's about very particular content. It's also about doing things. This knowledge is generated in particular ways through investigations, asking questions, collecting data, analyzing the data, coming to conclusions using evidence. So that's a method and a process. So all of you who thought this, you were correct as well. This knowledge is generated through particular scientific processes. And then finally, science has its own nature. Science is a way to come to know the world. And this way to come to know the world really imposes on this inquiry and helps create new knowledge.
好，那我们快上来是一个的，它是谈到可以从这三个角度去看什么是科学。大部分谈到科学的内容，然后呢，其实也有包含了科学的方法和过程。科学的方法过程比较像是我们今天可能谈这个探究那样的历程。最后的那个谈到的是知识它的本身有一些特性，那也是我们在谈科学的时候一方面的思考。
Okay, so we're going to switch back and forth. Okay, so one thing that's important now that we know your background better is this second part. Okay, in scientific inquiry, what the goal is, we're trying to answer the question that we don't know the answer to. And when we get the answer, we develop new knowledge, which is one of these things. In engineering and in technology, it's a little bit different. Because most of the time, we're not trying to find an answer to a question that we have no idea what the answer is. We're trying in engineering and in technology to produce a certain product that can function a certain way in a certain situation. We may not know what the best design is, and so we may experiment with different designs. But we have an ending point in engineering and design. And often instead of using the word inquiry, in technology and engineering it's called engineering or technological design.
这个刚刚弄嘛，他在这个台上，我们比较在乎的是第二项。那在科学探究里头呢，多半我们是来自一个问题，而那个问题是可能是不知道的未知的问题，然后去探究那个问题找出答案。但是在可能工程啊科技的这个领域，在乎的是设计本身，而它的设计呢，其实它背后也有一些规范，就是说你的目的是要能够可能有效率，有什么等等的，所以那个是就是目的导向的一种特性这样子啊，所以他谈到我们要有一些产出的物品，那个物品呢本身必须要符合什么标准。
But often in engineering and in technology, in the process of development, you actually find out new scientific knowledge. So it has both. So there are slight differences between science and technology, but they go hand in hand. Scientific inquiry, as Judy said, is very confusing to a lot of people because it has many different or several different definitions. And that's why when someone says inquiry, you need to talk with them a little bit more to find out what they're talking about. Because they may be talking about one thing, and you may be talking about something else. In the grant that you're in, the project you're in, on the cover it said innovative teaching. Okay. Inquiry can be used to describe a particular teaching approach, which currently is considered to be the most effective and the most innovative way of teaching. And we have scientific inquiry here. You can be teaching in a vocational course or in a science course and teach using this approach. So it's not limited to a science class.
他在谈一下那个科学探究，其实有各个不同的定义哈。我们当时在执行这个计划，我们也是有些被问到说，我们谈的科学探究大概是什么？那他等一下会跟我们厘清。那第一个，他先谈到它可以是一个教学方法啊。那这个教学方法呢，它不一定是只有在科学课程里面才算啊。它教学方法是一种比较创意的，它可以在大家跟科学、科技任何有关的科目里面都可以用这样的探究的教学法。
Okay. And what that means is, rather than the teacher just talking to the students, and rather than me directing everything, you would start with a question or a problem that the teacher can give the students, depending on the students, the question or problem. Or the students can come up with their own question or problem. But the main focus is, you now have a question or problem, and from there, you decide how you're going to answer that question. You decide how you're going to proceed. So it's very student-centered, and the teacher just guides the students along so they don't go too far off the top. Okay? And that's true no matter what kind of class you're teaching.
就这样的探究教学呢，它就是来自于一定从一个问题开始，老师必须先引导一些问题，然后呢，它的这样的特性是非常学生中心的，以学生为中心。
And the rationale behind this is that students will learn science better if they participate in the same type of way that scientists learn about the world. If I have my students trying to answer questions, which is what scientists do, if they go through that process, they'll learn science better than if I just tell them about it.
那他大概谈到就是说，刚才学生中心，那学生对于这样的问题和这个解决问题的过程，他们有权和他参与哈，所以呢，这样的学习效果在他们研究上是比较好。
Now, and we'll give you some examples of this in a little bit. here's the part that people often forget about. That this teaching approach is designed to teach concepts, the theories, the laws, the principles in a way that scientists learn about those. But while they're doing inquiry, they're learning about that process. They're also learning the skills involved in the process. And those are outcomes of things you want your students to know. You don't just want them to know the content. You want them to know about how the content is developed. You want them to be able to do the things that scientists and engineers and architects do when they're investigating questions. And that's what these two things are.
大概就是说这样子的教学的成果哈，产出单纯只是就是学生学习到的一个概念啊，就是理论定律等等的，还包含了这些知识哈，跟这样知识的产生的过程哈，它背后是要有人哈，科学家或是科技研究者等等。
Okay, so this first one, which pretty much people understand what it is students are doing things, and the types of things that they're doing. And this is probably the best place to look. They are learning how to observe or collect data using their eyes, thermometers, they're measuring things, they're looking at chemical reactions. Any way that you collect data is considered observing and measuring. And sometimes they see patterns or differences between the things they're observing, and they do things that we call classifying. They make inferences, predictions, they ask questions. These are all the things that scientists do when they're trying to learn about the natural world. These are all the things that engineers do when they're trying to produce something that helps us easily live in the world we live in, or help human beings adapt in a way that doesn't destroy nature. Those are, in science, often called process skills, but the thing is that it's the things that students, the skills are learning to do.
这个地方就是谈到那个科学就是所谓的过程技能的部分，那大概都会列出来，我们希望学生完成达成的能力，包含他如何观察，运用这些工具去观察、测量，然后还有一些最后那个推论预测等等的，就是科学家或者科学研究者在做的事情。
Now here's the difficult one. We're going to get that. Okay. These are just from the United States standards about what you want students to do in terms of inquiry. We want them to identify questions. I think they're all high school. Okay, so it's high school, which is where you're at. You want them to identify questions, design investigations, use technology and math to improve what they're doing, develop explanations, and look for alternative ways of doing things. So that's what we expect in the United States, at least, our high school students to be able to do with respect to inquiry.
这是来自于美国的课纲，那他们就是分不同的学习阶段，那这个它呈现的就高中阶段的，它强调的就是在9到12年级学生能够做它就是强调那个可以做科学探究，那这些所列的就是学生的能力学习的能力指标来讲。
Now here's the thing that only teachers know. Students can do things and do them in the way you want them to do it, but they don't understand what they're doing. Okay? They can follow your directions and do things, and they don't know why they're doing it and what it means, and this is what this next one is about. It's the knowledge about inquiry. So this is not doing anymore, but it's thinking about what you can do.
好，那刚刚那所列的呢，就是说，觉得我们只是告诉学生怎么做哈，就是知道这么做照着我们告诉他们的那些东西，他们学到那些做法，但是从来没有问为什么要这么做。那这个是另外一个更面向，就是知道为什么，就是有关那个科学到底是什么。
Okay. So, just an example. You all know how to breathe. Inhale and exhale. Okay. You're breathing normally right now. Can you breathe at a more rapid rate? Can you breathe faster?
然后呼吸，我们每天都在呼吸，但是问说可不可以控制呼吸快一点？
So everybody can breathe, and everybody can control whether they breathe faster or slower within limits. Who can explain to me how you breathe?
我会这么做，但是